Hey guys, we're going to go through a little explanation of the tables that are in the National Fuel Gas Code book. I'm going to be going out of the outline again and specifically talking about item number 3, which is the explanation of the tables of natural gas. All of those tables are going to be identified in 6.2.1A through 6.2 all the way to X, and I'll show you exactly where those are. So 6.2.1A, what you're going to be looking for is specifically right up on the top here. You'll even see the type of piping materials that we're dealing with. You'll also notice that later on we're going to see as we go through this. This is the last one, which is basically going to be 6.2.1X, and that's for the polyethylene plastic tubing. This is the type of tubing that would be the same as what utilities are using, or if I'm going to run a building out to, if I'm going to run a gas pipeline out to a garage or something, that's what I would be using, is something like that. All right. So specifically the gas type of that we're dealing with, obviously, for Schedule 40 metallic pipe. Also, I wanted to point this out. Everything in natural gas on this thing is going to have an item number 2. So you'll notice that a 2 here, a 2 there, all those were 2. So essentially, the big thing that you have to really remember is to make sure you are in the right type of gas. You got to make sure your gas pressure, inlet pressure, is correct from the point of delivery. So wherever that of the regulator is that you're starting from, and you want to size that line, that's the one you got to be looking at. The pressure drop is another area we'll have to deal with, and that would be essentially what are you saying is going to be the allowable pressure drop of your system. I put a note on here for the most common table that I normally use for most of my stuff is essentially table 6.2.1B, which has a 0.5 inch water column pressure drop. And that's without a doubt the most common for Schedule 40 systems. So when I look at the code book, I'll identify specifically which one we're dealing with here. There we go. And of course, 6.2.1A has a pressure drop, as you can see, that's going to be 0.3 inches. And you'll notice the inlet pressure, which is another thing that I chatted about today, is essentially saying less than 2 psi. That when that inlet pressure that's less than 2 psi, that would pretty much be anything that's a 14-inch meter, if you can get one of those. There was a time when they would use those regularly if people needed it. Nowadays, it's going to be harder to find a utility that'll do that. And most of the time, the most common example would be, would without a doubt be a 7-inch water column, gas supply pressure that would be in there. All right, a couple other things that I'm going to point out here. You'll also notice the Schedule 40 pipe. So there's your piping material. You're going to notice the pipe sizes. So in other words, those are identified by nominal. So a 1/2-inch pipe, they are guesstimating that has a nominal ID of 0.622. And a 3/4 inch pipe, of course, is 0.824. So I know it's not exactly perfect for those dimensions for what you would say is 3/4 of an inch, but that's what they do. Item number, the next one, obviously 1 inch and so on. So they're just identifying nominal pipe sizes. The length on the tables are essentially, they give you it in feet. So there are, up to 10 feet, up to 20 feet, up to 30 feet, up to 40, and so on and so forth. The tables go pretty high. I mean, they get up into the 2,000 feet distances. It's pretty incredible how big they go. So specifically, when we look at the pressure drop. So you've got inlet pressure is one of those. The pressure drop, item number, so you got gas type, inlet pressure, pressure drop. Specific gravity is the one that is generally not going to be an issue of anything we got to worry about. The inlet pressure or nominal pipe size I chatted with you about already. And then the next one is basically picking the highest pipe size. So in other words, in this example, this gets a little bit into the usage of the tables. So for example, if I've got a system that's at 43 feet, for example, that would mean that I would then, if I'm at 43 feet in my system, so if I have a job that's 43 feet, I'm not going to round it down to the 40. What I would be using is I would be using the 50-foot roll. So then I wouldn't even look at any of the other rows other than just this particular roll in the 50-foot column for that particular size section or pipe. So that's typically how it's done. And I'll go into the sizing later. So and that's how I explained it too in the handout. So the next thing that you got to do is you got to convert the BTUs over to cubic feet. And that's the only thing you're going to have to do is for natural gas is you're going to be setting that up. So for example, I'm going to go back to this picture here, and the natural gas system, for example, if let's just say, for example, this was a 50,000 BTU appliance, and this one here is 50,000 as an example, and I'm going to keep it easy math. That's 100,000, and this one is another 50,000. So the heating value of the fuel is essentially going to be, you'd have to know what that number is, but I'll just say we'll use the number of 1,000 BTUs per cubic foot. So the way that we have to figure this out is essentially every appliance, if I take the BTUs of 50,000 and I divide that by, this is BTUs, and I divide that by BTUs per hour, and I divide that by the 1,000, which is the heating value, and that's how many BTUs you get out of a cubic foot. So your end result then ends up being, as you guys are familiar with this, is 50,000 divided by 1,000 ends up telling you that you've got 50 cubic feet per hour of fuel. So that means there's 50 cubic feet per hour in this line. You got another 50 over here. Cubic feet per hour. This one is also 50. And this one is 100. So that pretty much puts me at, when I think about it, if this is my main line and I'm feeding everything in this main line, that means I've got to carry everything in that line. And then once I get down to this next section, then I'm divvying it up and hey, I just got rid of 50. And I keep on moving down, and what's left over? Well, I just got rid of 50, so if it's 150, 250, that means there's 200,000. That's got to be carried on here. And so you get kind of the hang out of this, that's what we have to be able to do. So, and then of course the other charts that we deal with in the other tables are just doing nothing more than either they're changing the type of materials, whether it's copper, whether it's high pressure, whether it's any of those, and that's what you have to kind of pay attention to on that. So if I go on to a few other ones here, you'll notice the number item, let's say for example, item F as an example on this one. That one's a Schedule 40 piping system that's got a 3 psi inlet pressure and a 2 psi drop. So that means you're pretty much starting at 3 and you're going to be left with 1 psi after the pressure drop is done. So that's not a super common one to use. If we go further on some of these, you'll start to notice now we're getting into semi-rigid copper tubing. So if a person is going to use copper tubing for their gas lines, those are the tables that they're likely going to start to use. You'll notice that this is a low pressure system, less than 2 psi, and it's a 0.3 drop. That's not a super common one to use. The next one is the half one. That would be more common, more typical. You'll also notice that it's K&L or ACR. In the handout, I've identified specifically about some of the issues related to that. So in other words, copper piping, it's also the soft copper that we're using. It's K&L. It's just, K&L assumes plumbing grade, and then that's all ID, and the ACR is assuming a refrigeration grade, and that's essentially based on outside diameter. So that's why the table values are showing what they're showing. So they're actually the same tubing with the exception of whether it's K or L, and it's just a difference of the way that they're describing it. So that's one thing you gotta kind of know that. And then of course the pressure drops. So I've got a couple of little descriptors in here as well. So for example, like there's another type of tubing that's called CSST. That's corrugated stainless steel tubing. You have to know what they call the equivalent hydraulic diameter size. That's going to be determined by that manufacturer, and they will give you that information. And then, of course, the last one is the polyethylene plastic tubing, and that's usually like the yellow stuff that you see run in the ground, and that's easily available and readily available for any type of underground application. It works perfect for that. So those are, and I'll go through some examples with you guys on sizing those types of systems. It works great. And we'll go back to the code book here, and you'll notice here there's all that changes is really just the pressure drops. You'll notice that and here's some copper tubing, and again natural gas. That's not the most common. I would say that this probably is the CSST is a little bit more typical. So for example, this is a very common table that one would use. This is 6.2.10, and you'll notice that the sizing of the tubing is by EHD, and that's a equivalent hydraulic diameter. So we have to figure out whether the size is a 13, a 15, an 18, a 19, and we got to find that out from the manufacturers of the tubing. And then of course, if I keep going further and further, then we'll just get into some of the other types, like there's a bunch of CSST, but the plastic tubing, that's a big one. So this would be a typical example if I'm going to run maybe a pool heater or something like that, or a garage. I want to run gas to a garage. It's ideal for these applications. So that, in a nutshell, is essentially the explanation of the natural gas tables.